all of the procedural stuff out of the way, we're going to actually dig into content. So the dimensional analysis piece is one I didn't directly cover third period because I was like, we've done dimensional analysis like 5 times. We should be good. And I made an assumption I should not have, and I know better. So we are going to cover it in depth today, a little bit better. And then we'll move on to the IMFs. Okay. So we're going to start here and we're going to look at how to calculate the molar mass of a compound. So wheel questions are starting. Eric, how do I find the molar mass of a single atom? Forget the compounds part for a second. How do I find the molar mass of a single atom? Eric, I thought I let you in. Hold on.
There
we go. Are there two,
the
Eric?
atomic mass?
No, I'm just gonna let you know that my Wi-Fi is being weird, so I might disconnect or something. So
Okay.
just
Thank
gonna
you for
let
letting me know. I appreciate that. Eric, yes, it's the atomic mass, which we find on the periodic table, right? So I'm proud of myself. I heard both those. Yeah, it's the atomic mass. It's on the periodic table. So if we're looking for something that's a molecule, okay, so we know where each individual atom is. When we're looking for the molecule, what do you think we do, Gurinder? Gurinder, are you there?
Yeah, I'm here.
Okay, so if each individual atom is on the periodic table and a molecule is just multiple atoms, how do you think we find the molecule?
By the subscript.
Yeah, so if we look at it this way, we can see sodium is here, okay? The little subscript here tells us the number, okay? That's a really bad circle. Let's pretend I draw better, okay, guys? Let's just pretend that's better. What the heck is going on here? That, okay, whatever, that's close enough. So sodium has no subscript. So Shiv, there we go, Shiv. What does no subscript mean on the molecule? Sodium has no
It means
subscript.
there's only one of the molecule. Or
Yeah.
like one of the atom.
Yeah, it's like a multiplier, right? Anything multiplied by 1 is itself. So we just don't write the 1. So this is definitely 1 atom of sodium. So with that in mind, thank you, Shiv. That was very good. First try. Look at you go. Tim, hydrogen. How many atoms of hydrogen do we have?
There's 1 atom of hydrogen.
Yes, perfect. What about carbon? Go ahead and do it for me since you're right there.
1.
Yep. So there's 1 hydrogen, 1 carbon, 1 hydrogen, 1 carbon. And last but not least, let me see. How many are in oxygen reet?
3.
Yeah, there's 3. See here, it has that 3. So there's 3. Okay. So do you guys remember when we first started Lewis dots and I showed you that math way to do it in addition to the way Mr. Herdem showed you to do it? So you had both available to you. The math one works all the time. His version is a more logic spatial awareness version. Whichever one works for you, I am very happy for you to use. I just want you guys to have access to both. Okay. So remember when we were doing that, we added up valence electrons by doing what? How do we add up the valence electrons? Josh.
Sorry, may you repeat that?
How did we add up the valence electrons when we were doing Lewis structures? If we had like a CO2, right? We turned it into a formula. How did we do that?
So you would put so you would draw the axe for each of the, to sort of represent each of the nuclei, and then you would distribute the, electrons to represent the bondings of each of them.
Yeah, you went a little farther than I intended, but it was amazing because it was a great review. So thank you for going above and beyond. That first part though, where we found the valence electrons, we turned this into a formula, right? Na plus H plus C, and then that 3 right there, that was 3 O's. So it was 3 O's. You guys have seen this before, right? The first time we did it, we put in valence electrons, but now we want to know atomic masses. So instead of valence electrons, what do you think we put in place of those letters, Aiden?
Sorry, can you repeat the question?
Yes, instead of valence electrons, what do we put in place of those letters, do you think?
Their masses.
Their masses. So sodium, right, is 22.99, right? Plus hydrogen is 1.01 grams per mole, plus carbon, if you look at the bottom of the box, is 12.01. And then we have 3 oxygens, which are each 16.00. Okay, you put that baby in your calculator and you end up with 84.01 grams per mole. Bum, ba, bum. That's the answer. You guys did it. So I want you guys to try ammonium phosphate on your own. Okay, try ammonium phosphate on your own. Do a rat meow. Man, the amount of videos is getting smaller and smaller. If you guys are going to put a video, at least put like a picture of your face or something. You know how weird it is talking to black squares? It's so odd. Like, for real. It's like, I could be talking to Shaq and I wouldn't even know it. Like if you had Shaq was your uncle and he was just chilling, like that would be cool. You should share that.
Miss Longley.
Yes, ma'am.
So when I saw that you were calculating the numbers, wouldn't the final answer have 3 sig figs?
This is addition. Addition. So what rule do we have for addition? And this is where QC 4.5 got tricky. This is addition. So what's happening?
We're adding, so then we have to line up the decimals. and
Yes,
then
it's the
go
last
down.
decimal they have in common, right? So if we have this, here, this has 2 places past the decimal, 2 places past the decimal, 2 places past the decimal, 2 places past the decimal. Therefore, this has to have 2 places past the decimal. Good question, though. I love that you asked about Sig Figs. Big win. What? Get it. All right, y'all should be working through this. I'll give you just another minute, and then I'm going to ask some people some questions. Actually, I'm going to give you about 10 more seconds. I'm going to start asking questions because I am impatient. I want to talk to y'all. Okie dokie. Let's see. Zainab, how many nitrogens are in this molecule, ammonium phosphate?
Three.
Yes, you caught it. How did you get 3? For anyone who thought it was 1, what would you tell them? I see you're not muted, but I don't hear you. So I don't know if you're talking or not, but I cannot hear you. Are we having some sound issues? Okay, I'm gonna let someone else help because I think that your microphone quit working for some reason. You can go ahead and check that out. Abby, why is it 3 and not 1? Because I don't see a subscript here.
Because of the little 3 that's the side before the P, since the 3 isn't a subscript of the 3, that we have to distribute the 3 to the N and the 4, which means we'll have 3 nitrogen and then we're gonna have 12 hydrogen instead of just having.
Couldn't have said it better myself. The way you distribute in algebra is the same way we distribute here. If it's outside the parentheses, it goes to everything inside of it. So we have 3 nitrogens, 12 hydrogens. Love that explanation. Super gold star to you, not store, star. Z, how many phosphorus do I have?
One,
And how many oxygens?
4.
Awesome. So now we are going to set up this equation. So Ashreet, what do I put for the actual equation that looks like this?
So you put N and then the subscript 3, or you multiply nitrogen by 3. So you put N in parentheses, and then you put 12 and then times H, and you add those together, and then you put plus P, and then you put plus 4 times O.
Yep. I'm going to do this vertically this time just to show you the Sig Fig rule because she brought it up. I want to make sure you see why we're rounding the way we're rounding. Okay. So 3 times N means we're doing, and you did that perfectly. So thank you, Ashreet. 3 times N is 3 times the 14.01. So let's see. Katie, where did that 14.01 come from?
The atomic mass on the periodic table.
Beautiful. So that ends up being 42.03 when we round it because we are keeping 4 sig figs because that's what we started with. We have 12 times 1.01. So that's going to be 12.12. And then we have 1 times 30.97, which is also from the periodic table, which is 30.97 because it was multiplied by itself. And then we have 4 times 16.00. So that's going to be 64.00. So when we add all of them up, we end up with 149.12 grams per mole. We have to put that down, right? So the reason we kept 2 past the decimal is because this is addition, which means we keep the last decimal place they had in common. We couldn't do more because then we'd be pretending to be more accurate. We couldn't do less because we'd be pretending to be less accurate. And this is determining the accuracy of the instrumentation used. And with addition, the decimal is a fixed point in time. So we base everything on the decimal for addition subtraction because it does not move. Even when we add and subtract from the time we were tiny people and didn't even know chemistry was a thing, we've lined up the decimals and added them down, right? Whereas multiplication, it moves around. That's why we have to count the number of sig figs. So that's why that exists the way it exists. Are there any questions on how to find a molar mass? That's part 1 for dimensional analysis, right? So part 2 is exactly the same. So I want you guys to give me that scale of 1 to 10 in the chat before we start doing these guys. Okay, so give me that scale of 1 to 10 in the chat of how you feel about finding a molar mass now that you've seen it. Does it make more sense now that you've seen it? Hoping it does. Beautiful. I love all these answers. Data is cool. Okay. So now we're going to do the dimensional analysis thing, which we have done in the past and we know includes those fancy schmancy railroad tracks. So we are going to talk through these tracks. So the first question says, calculate the number of molecules in 2.97 moles of cyclohexane. Okay, so Brooke, what do I need to start my railroad track with?
2.97 moles.
Yes, 2.97 moles. So 2.97 moles of what? Because remember, we talked about we are starting good habits. We always write what we are talking about in the railroad tracks because in stoichiometry, when we get back from Christmas, you're going to have to keep track of like 3 or 2 or 4 at a time. And so if you don't start that habit now, it's going to hurt a lot later. So which one are we putting in the parenthesis right there?
Oh wait, still me. Nothing.
Right, what compound we're dealing with, right? C6H12. And then we set up our railroad tracks. So here is the $1 million question. Carter, how do we go from moles to molecules? Are you there? Did your internet kick you? You predicted that might happen. It did happen. He predicted it. He will watch this video later and hear, I was right. Yes, you were right, Carter. Your internet sucks. All right. It's okay though. Rafid, how do I go from moles to molecules? What the biz?
You use the Avogadro number.
Yes! Oh, you did not say molar mass. I am so proud of you. Give yourself a pat on the back. High five. Haha, made you clap. So good for you. Yes, we're using Avogadro's number because an Avogadro number, 6.022 times 10 to the 23rd, is a count. A mole is a count. It's a count. It's a count. It's a count. You could have a mole of atoms. You can have a mole of molecules. You could have a mole of moles, right? Like little ground moles, like, right? You can have a mole of anything. It's just like a dozen. So we're using that when we are counting the number. So next question. I'm so proud of you, dude. All right. So Olashan, how do I set up the next part of my railroad track then? We know we're using Avogadro's number. And just to remind everyone, Avogadro's number is 6.022 times 10 to the 23rd molecules. Okay. How do I set this up?
I'm not sure.
Okay. So let's take a walk down memory lane and remember that we have moles on the top. Do we want moles at the end of our problem?
No.
No, what are we looking for?
Molecules.
We're looking for molecules, right? So how do we get rid of moles?
Oh, you cancel it out
Yeah, how do we cancel it out?
by putting that, what do you call it, under it?
Yeah, on the bottom of the next one, right? So if it's here, it has to be there. So we get 1 mole of C6H12 because it's on the top and the bottom, the cancel, right? Beautiful. What do I put? I'm going to pick on someone else now. Good job, friend. What do I put on the top of that, Makunta? So we have moles on the bottom. What do I put on the top? Makunta. We've already discussed how hard it is to sing the alphabet, the name song with your name. Here we go. I see you. Are you there? Someone text him. Be like, dude, she's calling on you. Because I'm calling him again in just a minute. Hold on.
Hello.
Hey, there you are. What do you put at the top?
I don't really know how to pronounce. Is it the Avogadro's number?
So yeah, Avogadro. So the way I talk, it's not avocado, but it sounds a lot like it. It's not avocado, it's Avogadro. So then instead of the k of the avocado, it's the g, and then the dough is dro, Avogadro. Okay. So Avogadro's number is on the top. Beautiful. So it's the 6.022 times 10 to the 23rd molecules of cyclohexane. Bum, bum, bum. So that equals whatever we multiply across as. And when you multiply across, you get the fancy number of 1.788,534 times 10 to the 24. Awesome. Cool. So I'm totally done, right, Alex? Am I done?
No.
No, why not? I did all that math. I put it in the calculator. I should be done, right?
No.
No, why not? What did I forget? Sig Figs. Beautiful. Love it. So I was given 2.97 and we multiplied. So what rule am I using to round these Sig Figs? I'll call on someone else, pick on someone else now. Jacqueline, what rule am I using for these Sig Figs? That's a 4. Oh, your microphone went off right as you said after you said
No, I was just like
Okay, never mind. Then you did just
well, I mean, I don't know like a specific rule, but I know you have to do it to the least amount of significant figures in the equation. So you would do it to 3 sig figs.
That actually is exactly the rule. So you said the
Oh, okay.
So yeah, we were given 3 Sig Figs. We multiplied, so we have to keep 3 Sig Figs. So we would count 1, 2, 3, round back. So that is 1.79 times 10 to the 24. Awesome. So now I'm done. Right, Anshuman? I'm done now?
No.
No. What the biz, man? I did all that work. I surrounded by Sig Figs. What did I forget now?
Units.
Units. What is my unit for this?
Molecules.
Yeah, molecules of what?
C6H12.
Yep, cyclohexane, C6H12, because everything else was canceled out. I'm with molecules of C6H12. Now for reals, I'm done. Thank you guys for humoring me. So try the next one on your own. Try the next one. Work the problem. It looks very similar, but kind of different. And Carter, my man, you weren't wrong. I called on you and you were gone. I'm going to ask you a question here in a little bit, okay?
Okay, yeah. They're working on my internet, and I don't know. It's just wacky. I come in and I just leave. Right, I was in the middle of typing to you that my mom told me that they're working on our internet and stuff.
Yeah.
Immediately it went down. I was like, oh, great.
Isn't
I don't
that
know
how
if
it
you
always
got
happens?
it.
You're like, thanks, mom. No. Yeah, no, totally. But I left like, well, because you weren't there, I was like, ooh, Carter did say his internet was bad. He was right. Like,
yeah.
If you watch the video, I totally talked to you while you weren't here, but that's okay. I'll ask you questions in a little bit. Okay, man?
Okay.
All right. Try to work the problem with what you see. I know you weren't here for it. Just do your best. All right, Amal, how did you start, baby? What did we put down first in our railroad track?
The 2.64, I think.
Yeah, perfect, right? We started off with the 2.64 times 10 to the 21 molecules. Wow, I can't write. Molecules of potassium sulfate, which is K2SO4. Awesome. I'm gonna put my railroad track down. Beautiful. Good job, baby. All right, next. Yadvi, what is this question wanting? What is the question asking for?
It's asking for the number of moles.
Moles of potassium sulfate, right? So we're given molecules and we're trying to go to moles, right? So what number do I need to use? Carter, what lets me go from molecules to moles?
Is it like the 2.0266 times the 10 of 23rds?
You were so close. Yeah, it was 6.022, but yes, it is that number. It's right up here on the top here.
Oh, where? Oh, yeah, that number.
But the fact that you pulled that from your brain space and you weren't even here, super proud of you, Bubba. All right, 6.022 times 10 to the 23rd molecules. Ah, wait, go back. Don't do that. 6.022 times 10 to the 23rd molecules. Stop, jerk. It's because I'm writing so close to the bottom. 6.02 times 10 to the 23rd molecules is 1 mole. So, Daksheen, how do I use this number to my advantage right now? What do I need to do with it?
Do you need to divide it?
Yes, divide it how? What goes on the bottom? Let me give you a hint, okay? We have molecules on the top. We don't want molecules anymore. So how do we get rid of this? How do we get rid of this word? Put it on the top or the bottom?
On the bottom.
Yes. So this number with the molecules in it right here, that is what goes on the bottom because we need to cancel it out. Remember, we can only we can choose which side it goes on because 6.022 times 10 to the 23rd molecules equals 1 mole. The words have values 2. So this is equal to 1. So we could, it's like putting 2 over 2 or 2 over 2, right? You can cancel it either way for every 1 mole. Good job. So now molecules is gone. We're left with moles of K2SO4. That is what we wanted. So when I put it in the calculator, I would get, if I put it in the calculator, I would get, let's see, I wrote it out here. 0.00438 39256. Sweet. I'm done, right, Nihal? Totally done. That problem's long. I didn't like it. Now I'm done.
No, because
No.
you need to put in the right amount of sig figs and scientific notation.
Yeah, you could put in Sig Figs. You could put in Sig Figs, or you could put in scientific notation. This one I would accept either, depending, you know, like if it was a QC, you'd have to do it the way they said, but you could write this one either as scientific notation or as the number, and I would allow it. So how do I do that Sig Fig thing then, Nihal?
Well, it was given to you in 3 sig figs, so you would write 4 point, or actually you would, it's 0.00438.
Yeah, so I heard you do it in your head. So can I mind read you a little bit? We ignored these zeros in terms of sig figs because they are leading the significant chunk. Therefore, they are not significant. We start with the first non-zero number, count 1, 2, 3, and then we round back to that third number. So we ended up with 0.00438. If you did that in scientific notation, how would you write it, Shivani?
In scientific notation, you would put 4.3 times 10 to the negative 1.
10 to the negative 1 would put me, 10 to the negative 1 would put me at 0.438. How many do I need?
2.
So if I did 2, it would be 0.04. So what I want to do is I want to look at where my decimal is in my scientific notation, see how many I had to move to get there. So if that's where the decimal is in scientific notation, it's always between the first and second number. We're gonna count. Oh, why does it keep doing that? That is so annoying. 1, 2, 3 back. So 3 to the left is -3. Okay. And the unit we're using is mole of K2SO4. Beautiful. So either one of these 0.00438 or 4.38 times 10 to the negative 3 are equally acceptable, and it's moles of K2SO4. And boom goes the dynamite. Scale of 1 to 10, how we're doing so far? Because I'm about to kick it up one little notch. We're going to add something we've done before to this concept. Make sure you've got it, and then I will show you what you're doing for your IMFs. Okay, looks like we're doing good. So try this problem. Try this problem. Do you guys know what this capital M means first?
No, I don't know that.
Moles per liter. That's molarity. So it's moles per liter. How many moles of dissolved stuff is in the water? But it's saying 62.1 moles of water were used. It wants to know how many kilograms were used. So just to be clear, this is kind of a misnomer. I want to show you guys what it is because we will be talking about it soon, but it's not necessarily something we need at this moment, right? Kind of a distractor. Focus on water to water. That's my last hint. Dude, someone's listening to election stuff. Who is that? Who is all woke? What is going on? That's funny. I cannot listen to election stuff today. It is too stressful.
I just laugh at them when they argue.
Yeah. All right, guys, water to water. Try to hit it. See what you got. All right, we're gonna see how y'all set it up. Amir, how did you start? Amir, are you there? Bum, 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 ba-dum. Yeah, you're here. I'll come back. Augustine, how did you start?
I'm not sure.
Okay, so when we start, we always start with the number we're given. I told you this was a distractor, so this is not the number that matters. We're looking at water to water, so we don't need to worry about sodium chloride. We're not going to worry about that, right? So how much water did I start with?
62.1 moles.
62.1 moles. And what is the formula for water? Anybody? Spacebar.
H2O.
Yeah, anyone who watched what was the really old movie that's way older than you guys are? The Water Boy, right? Gatorade, H2O. Anyway, so most people know what water is, right? So 62.1 moles of water. We're gonna put that in our railroad track. All right. So we're trying to get to kilograms. Okay. Can we go from moles to kilograms directly? Mahek, can we go from moles to kilograms directly?
No.
No, but what can we get to that's a lot like kilograms?
I don't know. I'm not sure.
What's kilograms without the K?
Grams.
Yes. Can we go from moles to grams?
Yes.
Yes. How?
I'm not sure. Oh, by something to do with the atomic mass.
Yes. What did we practice when we first started? Finding the molar mass of a compound. Guess what? We have a compound. So we're just going to use the molar mass of the compound we practiced making, and that will get us to kilograms. So the reason I'm doing this right here on the bottom is if when these problems get complicated, you make a plan, right? Kind of like most things. I need to get from moles to kilograms. I can't do that directly, but if I go from moles to grams to kilograms, now I've got a plan. So I'm going to go from moles. So this is moles to grams to kilograms. Now I can set it all up. Does that make sense? So for every 1 mole of H2O, how do I tell how many grams I need Ethan, how do I get to the number of grams in water for every 1 mole?
You find the molecular mass of water.
Yeah, so H2O is going to equal 2 H's plus 1 O, right? So that's equal to 2 times 1.01 plus the 16.00. So that would give us 18.02 grams per mole, right? So if I have 1 mole of water on the bottom, because I want to cancel it out, I would have 18.02 grams of water on the top. So now I'm left with grams of water. But is grams what I wanted? Janie, is grams what I wanted originally?
No, we want kilograms.
So how do I get from grams to kilograms?
I don't remember the exact conversion number, but
Okay, so
You just add kilo to it.
yeah, kilo is 10 to the third, right? But there's 1,000 grams for every 1 kilogram, right? Kilo means 1,000. So that's why kilogram is equal to that. It's like saying 1 times 1,000 grams, because that's what kilo means, right? They're the same thing. So 1,000 grams is 1 kilogram. So the very last question, but then you knew the conversion, you just had to look it up, right? So if you don't know the number, you can use reference packet, look it up. Brandon, how do I set up this last little railroad track here?
On the bottom, you put 1,000 grams, and then on the top you put 1 kilogram.
Beautiful. And when I multiply all that together, I get 1.119042. Sweet, I'm done, right? Jana, am I done? Jana, Bobana, Banana, Fana, Fofana. Are you there? I'm going to sing the song to no one. I see you. Boop. It's okay. We can come back. Are you there?
Did you say my internet is really lagging? I can barely hear you.
Okay, I was asking, is this my final answer? Do you know what? I think your internet's giving you a hard time. So let me ask someone else, okay? Let's see. Tim, is that my final answer?
Wait, where am I looking? I'm sorry.
Right here, where the purple is. Is this,
That is not your final answer.
what do I need to do?
You need to do the Sig Figs to 3.
Yes. So how do I do that?
It would just be 1.12.
And then what would be my unit? Look at what's left over.
It would be grams grams of H2O or H2O gram. Oh
Yeah.
wait, no, that is kilograms. My bad. I didn't see the K.
Yeah, kilograms of H2O. Beautiful. All right. That was all I had. If you want to, but for this part of it, the dimensional analysis, I have this extra problem here. If you want to try it and then text me your answer in the chat to see if you got it right. I can tell you that it is, actually I just put it in the chat. If you want to try that last problem, the answer is 0.04565 moles. So you can try that one out. But for the rest of class, I had you guys join that collisions game, right? So if you go back to that collisions assignment, I want you guys to spend the next 20 minutes working through it. The reason it's really important is because it actually demonstrates to you relative IMF strength and weakness and teaches you how to build them. And if you can build them, you can do them. So on my side, when you join the class like that, I can actually see your progress, like what level you're on, okay? So I just want you to play for 20 minutes and get as far as you can. I'm gonna go to the teacher portal and show you what I can see. Yesterday, a lot of people started playing the wrong level, okay? You need to play the IMFs level only. So the link to play is in the Canvas assignment. And if I click this class, I can show you, if I go to IMFs and I look at progress, I can see every individual student's progress. So I'm going to put you in breakout rooms. I'm going to make them a little bigger. I'm going to put you in breakout rooms. And I want you guys to try to get at least to like level 10-ish. That's the goal in the next 20 minutes. Sorry, I was answering a question in the chat. The next 20 minutes or so, that assignment again is in Canvas. So I'll be able to see your progress. If while you're in that breakout room, you're not making much progress, I'll jump in to help because I'm going to put you guys in bigger rooms of like 5 to 6 people. Okay. So the collisions game is there. There's 2 links. One is to join the class. And then once you've joined, the next one is to start the game. So the first link, join the class, then the second link using this. I will see your progress. And then after that, you're just working on the QCs and the practice test. Okay? All right, guys, thank you for being flexible. I really appreciate you. When you're ready, go to your breakout room, go play the game.
Miss Long, if we had a question regarding 4.4, do you want us to come back after? Or are we going to come back after the game?
Ask me what's up.
Okay. All right. So, I was doing it yesterday because I thought we had to do the activities too. So I got a head start on it.
Yeah.
So I was looking at the one about I think it was, what was the word? I think it was, okay, it was a resonance one.
Mm-hmm.
And it was the one about the IMF levels from strongest to weakest. I'm confused. Like,
this game will help you with that, with the strongest to weakest. And what I'll do is I'm going to give everybody an extra attempt because of the confusion yesterday. I did that already.
Okay.
So everybody should have 5 attempts instead of 3 because a lot of you did 3 already, or it's either 5 or 6. I forget what I did because a lot of you guys saw it and tried to get ahead, and that it wasn't fair. That's why I was like, that's why I was trying to help. So
okay. All right,
everybody should have more attempts now. So do the game and then come back to it, see if it helps.
Okay. All right. Thank you.
No problem. Gurinder, go back to the assignment in Canvas. In that second link is all the game apps, and you go to IMFs.
Thank you.
No problem.